Welcome to Dev Trends on the Go. Today's Qiita Picks. I'm your host, and today is Thursday, July 30th, 2026. And this program is, as always, perfect for your commute.
Yeah, thanks for having me again.
Yeah.
And before we get into the actual trends today, for anyone listening from outside of Japan, we should probably clarify what Qiita actually is.
Right, yeah, good call. So Qiita is basically the Japanese software engineering community's premier knowledge-sharing platform. So if you're familiar with dev.to or Medium, it's essentially their equivalent to that.
Exactly. It's where developers go to share, architectural breakdowns, debug logs, and just debate system design in general. It's really the best place to see what the industry is actually struggling with on a day-to-day basis.
Yeah, and today our mission is to catch you up on the most interesting dev trends happening over there right now, keeping you informed without the massive information overload. And real quick, before we jump into the first article, if you enjoy this kind of breakdown, take like a half second to hit subscribe and like the show on whatever app you're using. It genuinely helps us out.
So getting right into it, the first big trend catching fire on Qiita right now is, unsurprisingly, about AI. But, the conversation has totally moved past the initial hype phase. We're looking at a piece by a user named Sumu, and they make the argument that the quote-unquote lack of experience barrier is just, well, it's completely gone for beginners now.
I mean, that makes sense. That initial barrier used to be all about syntax and boilerplate, right? Like setting up a local environment or configuring a router could take a beginner weeks of tutorials.
Yeah, exactly. Now you just prompt an AI and it scaffolds the entire project structure for you in seconds. But there's another side to this. A second article by Qiita looks at the more advanced end of the spectrum with Claude Opus 5. And they point out that how we write prompts is fundamentally changing. Like, we don't need to write those explicit defensive instructions anymore.
Oh, wait, I saw that one. They mentioned we don't need to add phrases at the end like, double check your work, or please verify this logic. But why is that? I mean, are we just trusting the black box more now?
It's not really about blind trust. It's that the baseline reasoning of the model itself has fundamentally shifted. So earlier models functioned kind of like eager text predictors. If you didn't explicitly fence them in, they just hallucinate something to finish the task quickly.
Right, just to get an answer on the screen.
Yeah, but Claude Opus 5 has these internal reinforcement layers. It actually evaluates its own logic before generating the output. So that verification mechanism is now just intrinsic to how it processes a prompt. You don't have to force it to do it anymore.
So it's like actively double-checking its own math in the background before it even starts streaming the text to my screen. That sounds incredibly useful, but I mean, I've also noticed my own API bills really creeping up lately when I use these autonomous coding agents.
Yeah, the API bill. That brings us perfectly to a really technical breakdown by Nana777. It's all about optimizing token consumption, specifically when using Claude code.
Yeah.
And the author zeroes in on the costs associated with RAG setups.
Okay, really quickly, for anyone who might not know, RAG just stands for Retrieval Augmented Generation, which basically means letting the AI read your reference material or code base before it tries to answer your question.
Exactly. And because you're using RAG to feed the AI external documents, you end up constantly reloading that exact same data into the context window.
Right, because otherwise the AI has no idea what my proprietary code base looks like unless I show it the specific files. But why is that getting so wildly expensive?
It boils down to structural costs in a stateless API environment. Every single time you send a new prompt, the API endpoint has zero memory of the interaction you literally just had.
Oh, wow.
Yeah, so it has to reprocess your entire conversation history, plus all those essential context files entirely from scratch. So for example, if you have a Claude G.md file, which has all your project's formatting rules, the system pays to load that into the context window on every single turn of the conversation.
Wait, really? So if I'm in a debugging session and we go back and forth 20 times, the system is literally billing me to reread my project guidelines 20 separate times.
It is, yeah. And the author highlights how our inefficient behaviors just compound this token burn. Like, if you give the agent a vague task without telling it which directory to search, it incurs this massive search cost. It'll scan every file in your repo, dump all that raw code into the context window, just to find the one single function you actually care about.
Oh man, okay. I'm trying to picture the mechanics of this. It's kind of like it's like hiring a super smart intern who has absolute amnesia every 5 minutes. So if you don't tell them exactly which drawer to look in, they'll just read the entire filing cabinet and then bill you their hourly rate for reading the whole cabinet every single time you ask a follow-up question.
That is a perfect analogy. That's exactly the reality of the API billing model because you're charged per word processed. So to fix this, the author suggests a major mindset shift, which is write for agents, not humans.
Okay, but what does that actually look like in practice? Because I don't know about you, but I tend to say please and thank you to my coding assistant just out of habit.
Yeah, we all do it. But you have to drop the conversational filler. Drop the emojis, drop the politeness, be brutally explicit with your file paths. But more importantly, you need to consolidate your tool calls.
Consolidate them how?
Well, instead of letting the AI run 10 separate sequential queries to read 10 different files, which triggers 10 separate expensive context reloads, you format your prompt to command the agent to read all 10 files in a single batched operation.
Ah, so you just eliminate all those extra round trips to the filing cabinet. That makes total sense. And this is highly useful for, AI-assisted developers looking to cut their API costs, and also for beginners who are using AI to bridge those skill gaps.
Exactly. But that tension, paying a high cognitive cost upfront to structure a prompt versus bleeding resources over time, that actually leads us right into optimizing how our actual infrastructure operates.
Oh, right. The infrastructure as code debate. We've got an article by a user named ToyaDay8, and they ask a pretty controversial question. Does IaC really reduce man hours?
Yeah, and just to define IaC real quick, it stands for infrastructure as code, which just means writing a script to set up your servers and databases instead of manually clicking buttons in an AWS or Azure cloud dashboard. It's a huge friction point for teams moving away from visual interfaces.
I can totally see why teams push back on it. Like if I need a new database spun up today, clicking through a web console takes me, 3 minutes? But opening my code editor, writing the syntax, managing the state file, and then testing that deployment script feels like a massive waste of time.
And the author completely validates that frustration. The friction is very real. You're dealing with state file sync issues, debugging these super cryptic configuration errors, fighting a steep learning curve. But the author's core argument is that judging infrastructure as code by the speed of your very first deployment completely misses the point of the technology.
So where does the actual payoff happen then if day one is so much slower?
The value is entirely in long-term reusability. The author points to AWS CDK specifically. CDK is a framework that lets you write infrastructure using familiar languages like TypeScript or Python, instead of writing thousands of lines of static JSON. It compiles your object-oriented code down into CloudFormation templates.
Okay, I think I get the mechanism. It sounds a lot like buying an automated coffee machine for a cafe, like calibrating the water pressure, setting the bean grind size, programming the temperature. That takes way longer than just making the first cup of coffee by hand.
Right.
But it pays off when you need to serve 10,000 cups exactly the same way. It just duplicates that first cup perfectly without human error.
Exactly. And in software, that means you can spin up a flawless replica of your production environment for staging in like 5 minutes, or instantly deploy a disaster recovery site in a different region. AWS CDK structurally forces teams to build modularly. You write the code for a secure web server once, and every other team in the company can just import that module.
So that initial slowdown is really just an upfront investment in reusability, not a magical shortcut for today's tasks. I think this is super useful for DevOps engineers and tech leads who are, trying to justify IaC adoption to skeptical management.
Totally. And speaking of massive infrastructure investments that take years to pay off, let's look at how the Japanese government is dealing with its own legacy architecture.
Oh man, this one is wild. We're looking at an exhaustive 10-year review by K2 Naka on quote-unquote internet separation in local municipalities, along with a related YouTube discussion.
Yeah, this is a fascinating look at how security architecture impacts daily operations. So some context for our global listeners. In Japan, local governments handle highly sensitive citizen data, like taxes and My Number national IDs. And they operate under a strict, legally mandated network policy called LGWAN to keep that data isolated.
How strict are we actually talking here? Like, what did this physical setup look like?
Well, after a big cybersecurity incident in 2015, they instituted what's called the three-tier separation method. They physically and logically severed the networks. So you had one completely isolated network for sensitive data, a separate network for internal business operations, and then a completely segregated terminal dedicated solely to accessing the outside internet.
Wait. So if someone emails a government worker a PDF from the outside world, how on earth do they actually read it on their business computer?
Right.
If the networks don't touch, the file physically can't cross over.
Right, so it required this agonizing sanitization process.
Yeah.
The worker gets the file on the internet-facing terminal, Then they send it through a dedicated system that strips out all macros, converts dynamic files to flat text or images, or uses virtual desktop infrastructure to visually project the file without moving the actual data.
That is insane.
I know, and in some older setups, workers were literally burning sanitized files to physical USB drives, scanning the drives, and then physically walking them across the room to cross the air gap.
I cannot even fathom having to do that dozens of times a day in the sauce era. Like, it's incredibly secure because malware physically cannot cross a gap, but the operational friction. You can't use modern cloud tools or collaborate on documents with a setup like that.
Which is exactly why they are currently undergoing a massive migration to a zero-trust architecture. And zero trust just means assuming every network request is already dangerous. So instead of relying on a physical barrier to keep people out, you continuously verify the user's ID and device for every single request, even if they're sitting inside the building.
Okay, so that means it's kind of like filling in the giant protective moat around a castle, and instead just checking the ID of every single person every second they walk around inside.
Yes, that is a perfect image. The moat is gone, but every door has a biometric scanner. The author points out that this architecture regains all that lost efficiency workers can finally use cloud tools again.
But
Yeah.
there's a catch, right? What happens if the central system checking those IDs goes down?
That is the exact warning raised in this retrospective. You're trading daily network friction for a massive availability risk. Zero trust relies heavily on a centralized identity provider. If that central ID checker goes offline, nobody can verify their identity.
So the entire government's operations just grind to a halt.
Wow.
Wow, that is an incredible case study. Really useful for security architects and network engineers who are managing these kinds of legacy migrations.
It really is. And, that massive transition cost actually ties perfectly into our final article about why large systems and even societies resist change.
Yeah, this last piece views macroeconomic issues through the lens of system design and behavioral economics. It's an article by Mascot 1977 about why labor shortages persist. And just to be super clear with our listeners here, we are impartially reporting this as the author's systemic framework. We're not taking any political stance on Japan's labor or immigration policies. We're just summarizing the source material's perspective.
Exactly. And the author's core premise here is really interesting. They frame a labor shortage not as a system error, but as an alert or a signal for evolution.
Okay, what's the difference between an error and an alert in this context?
An error is a broken component you fix, so the system runs exactly like it did yesterday. An alert is a signal demanding adaptation. In theory, a labor shortage should naturally force a system to evolve, like driving wages up or forcing heavy structural investment in automation.
Right, but humans hate change.
We do. We overvalue transition costs. People prefer patching the system with cheap workarounds like bringing in temporary labor rather than fixing the root cause, which might be low wages or a lack of investment. The author argues this financial illusion acts as a cognitive bug that prevents necessary system refactoring.
Oh man, how would you actually use this at work? Because it sounds exactly like ignoring a compiler warning in our code, because refactoring would take too long, but eventually the technical debt just crashes the whole app.
I completely agree. It's the exact same mechanic. The author's ultimate point is that true system design requires creating mechanisms that force continuous improvement, rather than just keeping the status quo on life support with quick patches.
Yeah, ignoring system alerts leads to technical debt, whether that's in software or economics. This conceptual crossover is highly useful for engineering managers and really anyone interested in systems thinking.
Definitely.
Well, that covers the top dev trends today. Before you close out your app, please take a quick second to subscribe and like the show.
Yep, and remember we have a new episode of Dev Trends on the go every single day, so definitely tune in tomorrow for a fresh batch of trends.
And we want to leave you with a final thought to mull over today based on that last article. If a labor shortage is just a system alert for an economy, what recurring errors or warnings in your own daily coding workflows are you patching over with quick fixes instead of actually structurally refactoring? Think about it. Have a great day and happy coding.